Just a few logistics before we get started. Welcome everyone to the day 2 of your Python with AI for Pharmacometrics workshop. Again, a big shout out to Dr. Datta for making the time and teaching this workshop. As you know, this workshop is going to be a 3-day session, and we had our day 1 on September 25th. Today, that is October 16th, is our day 2 of the workshop. And the day 3 of the workshop will be October 23rd. So we are entering day 2 of the workshop, and you will have only 1 week between the day 2 and the day 3 of the workshop. I do understand that some of you have completed the homework assignment that was given on day 1, and some may not have yet done so. I just want to emphasize that completing the workshop or the homework assignment would be a critical piece for you to get the completion certificate. To make it easier for the participants, we are actually not going to be holding you accountable for the date of the completion of day 1 of the workshop. However, we would hold you accountable to complete all the assignments given before November 10th. And only if you have submitted all the assignments by November 10th, you will get a completion certificate. Okay. With regards this, if you have any questions, please post it on the chat. I also do want to talk about a few other logistics. One is we have created a Google Classroom. You should have received an email with the link to the Google Classroom. The Google Classroom is where you can post your questions. The Google Classroom is also where you will have access to all the slide decks, the homework assignments, the code, and you can even post your questions on the Google Classroom. The reason why we are looking to do, I know at some point we thought we'll do a WhatsApp channel or do a Slack channel, but now we are choosing to keep all of the information in one location. And that is the reason why we have chosen to create a Google Classroom. Okay. You should see a link to the Google Classroom also in the chat. Dr. Datta just posted it one more time. So if you're not part of the Google Classroom, please join it there. That's where Dr. Datta will be answering questions, and also you will have access to few of our tutors who can help answer any other questions that Dr. Datta may not have had the chance to get to. All right. That's where you can also exchange knowledge within this as well. Okay. So with that, I will hand this over to Dr. Datta to carry on. So let me stop sharing.
Everyone, so this is the day 2. Very excited. I have seen the answers and assignments many of you have posted. So looks like we are on good track. So let me start with a few slides. So I'm going to share my screen. All right. So let me just start with a few slides before we move on to the material. And this slide deck is also posted in the Google Classroom. This slide along with other links. So we and this slide deck will also have the links to the notebooks which contain the material that we are going to cover today. So what today we are going to do is we will start with some more of Python concepts that we did not cover last time. For example, more data types like sets and tuples and dicts. We will talk about Pandas data frame and how to read Pandas data frame from CSV files. And then we will talk another concept, which is joining data frames, which many of you might be familiar with already. And so we'll just go with the syntax of joining in Python. After that, we'll move back to the topic that we had started before. So if you recall, so last week we started the task of fitting data to Python, and we did that using compartment model. We use curve fitting, and today we will continue that process, and we will introduce random forest. So that is a popular AI/ML method to do curve fitting, and essentially the principle of curve fitting in AI/ML is that do we need to always have a model, or can we just fit without, if even when we do not know what kind of a model is going to fit this data? So that is what we will explore. So at that time, before we start that, we will also quickly review assignment 2, but that we are going to do after we have talked about data frames. This is week 2 homework. We'll talk about it again later in the class. In this slide deck, I have also put a few links that you might want to later visit and see. So the two links here are quick reads. One of them is an article which talks about how to build the same application in R Shiny versus R Python versus Shiny in Python. So for those of you who are familiar with R and want to see how uh, what are the equivalent commands for doing the same thing that you might already know how to do in R? How do you do the same thing in Python? This is a good uh, quick overview of showing you some of the common things in R, how they are done in Python. And it covers data as well as applications like Shiny and plotting. Next one is a short opinion piece. It just talks about what are the things that R is good at versus what Python is good at. And then in this particular sheet, I have provided you 3 links, which takes you to websites which are more deep dives. They're not quick reads. One of them here is a PKPD modeling course. It's written by Matthias Koenig, and here you will find lectures. Actually, maybe I will go to the README. It gives you a it gives you an overview of how to do various pharmacokinetic modeling things in Python. So after the material that we are going to be covering in the 3 lectures as part of this workshop, you you will be in a good position to do more deep dive and use more material which talks about which covers the things in depth. So for example, some of the things that is covered here involve how to calculate PK parameters, how to handle variability, and in particular how to use libraries that relate to SBML. Okay, so that's this one, and you will find the link in this slide right here. And then there are 2 more links which takes you to tutorials about Python. One of them has a more data science focus, and the other one, Introduction to Python for R users. You can call it a more deep dive version of what I mentioned before. That is telling you side by side, telling you if how you do certain things in R versus how you do the same thing in Python. Okay, so these 2 slides you will find in the slide deck. And then next week, one of the topics we will cover is covariate selection. We'll talk a little bit about the need for it at the end of today's talk. Uh, but next week we are going to cover it in more detail, and we will also have a guest speaker, Nathan Tusher. Nathan is, you can call him, he's a subject matter expert, a consultant with more than 20 years experience in pharmacometrics. He's also a blogger and also um, an entrepreneur. He has started his own company offering pharmacometric solutions. So he will be there next week. He will talk about the covariate selection topic and also might answer if any questions you have for a practitioner who has been using both Python and R for pharmacometrics. Other than that, I have kept the syllabus for next week somewhat open. So if you have any particular topics that you want to cover, you can post it in the classroom. If you go to the classroom, you will find that there is a question, and I'm going to go right there. Um, okay, I don't have the classroom link here. There you go. So if you go to the classroom, you will see all the slides and various things. I've also posted a question. Are there any topics you would like to be covered? So you can just, if you have any thoughts, please post your comments right there, right here. Okay. So with that, I'm going to jump into the first action item for the day, which is to go over things like more Python data types and data frames.
Somdip, just a quick note. Um, would it be would it be possible for you to also cover the homework assignment?
Yes, I will
Um,
cover the homework assignment halfway through the course before I go into more data fitting topics. Because the homework assignment is more related to data fitting, so I just didn't want to do that and jump to data frames and come back to it. So after I have covered, in the next half an hour, I'm going to cover certain topics about Python data types. Then I will talk about the homework assignment of week 1, and then we will go into more data fitting topics.
Thank you.
Okay. Okay. All right. So let's start here. Last week we went through some of the common data types in Python. I think we covered floating point, we covered integers, strings, and lists. And then we covered NumPy arrays, which is a more efficient implementation of lists when it is numbers only. One of the a few items that we skipped last time, but is nevertheless quite popular. So among them, uh, the one that comes to my mind is dictionary. So what is dictionary? A dictionary kind of looks like this. It's more like a map. So for example, let's say I want to keep a tally of which study name, a mapping from a study name to number of participants. This kind of mapping is also called key value pairs. You may have heard the term. So dictionary is a good way to keep such a mapping. So in this case, for example, I am using this curly brackets, and then I write this mapping. Study 1 maps to 500 participants, study 2 400, study 4 500, right? So this is going to create a dictionary. Right, to wait a little bit for it to connect. All right, now let's see what did we create. Subject count. So that's the dictionary, and let's see what's the type. So Python calls it dict. Now, what are the things that we can do with dict? One is we can check if a particular key exists in this dictionary. For example, if we want to see does study 1 exist in subject count, all we have to do is write something like study 1 in subject count. The answer is true. Study 5 in subject count. Ah. And the answer is false. Okay. So you can see that the syntax of Python is quite English-like. All right, we know that study one is in subject count, but how do we extract the value? So there are several ways of doing it. The easiest one is just put a square bracket and do study one, and this is going to extract the value. Of course, we can also do something like this. Let's say this is in a variable name, study name, and I'm going to check if this one is in subject count. Okay. Well, that brings a question: what happens if I try to access a study which is not in the mapping? So let's just do subject 5, study 5, and attempt to extract the value from this dictionary. All right. You can see this leads to a error. So your program is going to throw, and you will usually see something like this: key error. Key error, um, yeah, it's one of the most common errors in Python. Key error, that it means you try to access a key from a dictionary which did not exist. There are some safe ways to do that too. Of course, you can also do, if you can check is if study name is in subject count, then only you can try to access it. Or there are other ways to try to access which would not lead to an error. And one of them is the get method. So what you could do is you can say subject count dot get study name. Actually, it didn't print anything. So let me just explicitly try to print the result so that you know what is actually returned. Right. So when you use the get method and you try to extract a key that does not exist in the dictionary, you get none. It does not throw, you basically get a none value. So you can then process it, and uh, you can write logic that if result is none, do something else. On the other hand, let's say you did not want none, but you want to put a default value that if the key does not exist in the dictionary, just get a default value. So let's say in this case, we want to say that the default value is 0. So we just put that as the second argument in the get method. So see, if I hover my cursor over get, it tells me the syntax of that get method. The first argument is key, which you always need. And the second argument is the default value. By default, the default value is none, but you can also make it something like this. It's a 0. So now if I run it, if this key does not exist in the dictionary, you will get 0. And if this key exists in the dictionary, you will just get whatever value that is. Okay, so I'm going to pause a bit. We just introduced another data type in Python, which is the dict. Okay. The next data type I'm going to talk about is the tuple. Now, in the last lecture, we had already seen a data type like this, 1, 3, 7, that you define with a square bracket, type A. This is a list. There is another similar data type in Python, which is called a tuple. And you define that using uh, parentheses, the round bracket. On first look, a tuple looks not too different than a list, except that the bracket is different. But it has some interesting properties. Most notably, tuple is what we call non-mutable. That means You can kind of do some similar things with tuple that you could do it list. For example, if I want to extract the element number 0, yeah, I got this. Element number 1 is 3. So far it looks like it behaves exactly like a list. But one of the things you could have done in a list that you could have assigned any element to a new value. Let's say I want to change element number 1 to 5. I could have easily done with a list. Um, well, why don't I just demonstrate that? Let's say if this was a list, not a tuple. So in this case, I defined the list as 137. I printed the type and I reassigned the value of element 1 as 5. And now you can see that the list has changed to 157. However, if this was a tuple and I try to do the same, so what we got a tuple, but then the moment we try to reassign, you're going to see this error. Tuple object does not support item assignment. What it means is that you can't change part of that tuple. What you can do is you can of course reassign A entirely. You can do you can say that, oh, A is now a new tuple. Instead of 137, it's 157. That is okay. But you can't say that, okay, just change a part of the tuple, just make the first element to be something else. That is going to give you an exception. Now, you might wonder, and it might not be immediately obvious to you, why would we even want to do this? But there are advantages. Something that is non-mutable often has better performance. It can be optimized. It can be optimized better, and certain things will run faster. And also, when you're writing a code, sometimes you want to explicitly choose to make your uh, list-like structure to be non-mutable because you don't want to accidentally change things. Now, having said all that, it might still not be obvious to you why you may want to and when you may want to use a tuple versus a list. But at the very least, I just wanted you to be familiar that there is such a thing as tuple as opposed to a list. Because when you're looking at somebody else's code, you will often find that it's a tuple instead of a list, right? So it's something that is important to know. Okay. Uh, well, we saw that we defined one kind of a collection using square brackets, another kind of a collection using round brackets. And one might assume that maybe Python supports another kind of collection with curly brackets. So let's try that. What is this? Actually, dictionary is also defined using curly brackets, but in the case of a dictionary, it's a key value pair. You have a key value, key value, key value. But what if we try to define something using curly brackets with just values? What you get is a set. The way a set is different from a list is that a set always has unique values. So, for example, if this was a list, again, I'm going 1, 3, 7, 7, right? And I defined it. I repeated 7 twice. In a list, it's totally allowed. But if this was a set and I have two values with two instances of the same value, and I try to create a set out of it, you will see that the set only keeps one unique value. It drops the duplicate. In fact, if if I had something like this, actually, I wonder whether add is a. Oh, it does not have add. Okay. Okay. Let's start with a list, which is 137, and try to put a new number into this list, which actually happens to be a duplicate of something which already exists. Oh, what happened here? Okay. Actually, the right command is append. Let's just append 3, and let's see what's the new way. Okay. So if we start with a list which has say 137 and we append 3, which happens to be a duplicate, a list won't complain. It will just add another 3. But in the case of set, actually in set, there is no append, there is a add. If you add a same element and you try to add it again, you will see that it makes no difference. It just keeps the same 3 elements. It will not add a duplicate element. If instead of 3, if it was 8, it will happily increase the set. So set is another collection. So I actually use the word collection because a list, a dictionary, uh, a set, tuple are different kinds of collection. They have just different properties, and depending upon what suits your need best, you would want to use one or the another. For example, if you know that you want to have a unique collection, that you want to use set, because then you don't have to have extra logic to ensure uniqueness. If you use list, then you will have to write your own logic, because list by itself will not ensure uniqueness. Okay, so I think we have covered a good material. We have covered the 3 more basic data types that we missed last time, that is dictionary, uh, tuple, and a set. So after this, we are going to jump into data frames, which is a big topic. So before I do that, if you have any questions about dictionary, list, tuple, let me know. You can type in questions in the chat. So we'll just give a brief pause. Yeah. So now we are going to go into data frames. Many of you who have used R, you're already kind of familiar with what is a data frame. A data frame is kind of something that looks like a table. It has rows and it has columns, and every column, some columns can be numbers, some columns can be string, and so on. It's the most direct equivalent of the data that you often see in a CSV file or in an Excel spreadsheet. You can call it one of the most fundamental ways of storing data before you process, do joins and plots. Now, one fundamental, well, Python also has data frames, but one fundamental difference between Python and R is that in R, data frame is part of the basic package. Whereas in Python, it generally follows the philosophy that the language itself is minimal. Anything extra, you have to use a different library. So in the case of data frames, the most popular data frames comes from the library called Pandas. So before you use data frames, you got to import this library. So import Pandas. And it is very popular to use an alias because you will be using the word pandas again and again. So you just use an alias, like you do a short form called PD, right? So by doing this, I have imported the pandas package and I'm calling it PD. So now anything from pandas, I will just call PD dot something. So let's create a simple data frame, and I can do that. So here I have defined 3 different columns as lists and a fourth column as a list of strings. And with that, I can create a data frame by passing it a mapping. In fact, you might notice that the argument to this data frame is defined using a curly bracket. It is actually a dictionary, something we saw earlier, which in this case, it maps the column name to the column value. The column name X to column value, which is defined above. So we are defining a data frame using a dictionary, which maps column names to column values. And just let's see what the data frame looks like. That is what it looks like, right? Another thing you would have immediately noticed is that the notebook, whether it's Jupyter Notebook or in this case we are using Google Colab, it has utilities to make it easy for you to operate or work with the data frame. So you would have seen this icons popped up on the right. So this one actually, even without you having to write a code, this simple app icon turns your data frame into an interactive table. This one is a short table, but it has paginations, and you can actually do filters and things like that. So it's almost like an app that you most likely would have needed. You don't have to write because just Notebook just supports it. Okay. All right. So that is my data, and yeah, it has utilities like what kind of charts you want to do and generate code to use. Yeah. So you get a lot of fancy widgets and tools that pops up in Google Colab as soon as you define a data frame. So when you try this in your Colab, you definitely experiment with all of this and see what are the things that you can do. And we're just going to see a few basic commands with the data frame before we move on further. Well, the most obvious one is if I have a data frame, can I extract a particular column? Yes, you can. Just give the column name just like you index an array and you will get this data. Um, can I get a particular row? You probably don't. Oh, you do actually. So from a particular column, you can also get a particular row, right? Um, Actually, let me try one more thing. Does it support plot? Right. So here's also the fun thing. So the data frame also embeds um, plot commands directly. So it instead of separately going importing matplotlib and passing it arrays, the data frame itself has a simple syntax to plot a um, certain column against another column. Right? Okay. So those are some simple things you can do with a data frame. So then the next thing I'm going to touch upon about the use of data frame is how to import and export data. So for example, here, let's say I have a web page, a URL in which I've got this data. This data, as you can see, is like a text file. It's separated by space, or rather separated by tabs. So if I want to ingest, all I need to do is fetch the URL, just copied it, and I will say, oh, this is my URL. And now let me just say data frame equal to PD, which is the alias for pandas. Oh, and it actually just prompted read CSV URL and use the separator as tab. And let's see what this data frame looks like. Yeah, it has successfully read this particular data. Uh, I have another text file. Did I miss? Small profile no header.csv. So if instead of a text file, I have a CSV file, comma separated, but no header. Uh, what I can do is, okay, let me just get this URL. In this case, and I will just say header equals none. No, just show the data frame is. So there you go. It was, you have to tell that there is no header. I think. And similarly, if it does have a header, oh, one moment. Yeah, actually, I have another file like this. It does have a header. So in that case, you don't pass this argument header equal to none. By default, it assumes that there is a header and it's going to read this. Now, of course, your data might not be in CSV or text file. It can be in many, many ways. But you don't really need to memorize all of that. I mean, what you can do is let's look for pandas documentation for IO. Let's see where it takes me to. Yep. So it took me to pandas documentation for input output, and you can see right here you have instructions for reading from many different formats, whether it's from CSV, JSON, HTML, SAS, SPSS, so, pickling, even Excel files. So it's all right here. Okay. And of course, like these days, you don't really need to memorize your syntaxes too much. If instead of going and looking for the documentation, you could just simply ask Gemini or your AI tool to generate the code. As long as you understand the concept, it's totally okay to, use AI to generate code. Okay. So I think we covered the main topics, simple details about data frames. Before I stop data frames, the last topic I will cover is joins. Anybody has any questions so far? All right. So what is a join? Well, I'm many of you are probably already familiar with what is a join, and you have done that in you've worked with it in R, but I will just give a short recap. So what a join does is, let's say your data might be stored in multiple tables. For example, in this particular example, you have got one CSV file that shows time concentration data by patient, and you have another CSV file which shows demographics data by patient. And this is a very common practice to split up this data this way, because otherwise your storage files might become too big if you want to have everything in one place. So in this case, the time concentration data has multiple rows for a particular patient, whereas in the demographics data, you just need to have one row per patient. And so it is more efficient to actually store it this way. If you want to combine these two pieces of data, uh, give me one moment. Right. Sorry, actually, my phone started ringing. Okay. So in this particular case, if we want to combine the two data and have a single big data set with both concentration, time concentration, and patient demographics, all we need is that both the data frames should have at least one key by which you can identify which one corresponds to what. So what I mean is, like, for example, in this case, the patient code is the key by which both which is common to both the data sets so that you can combine them. And how you join, let me just get rid of this code. Uh, the things that you need in order to join is the data frame command merge. So in Python, the command is called merge, and the minimal arguments that it needs, the data frame 1, data frame 2, and the name of the key with which you are going to join, which in this case is patient code. Now, if you merge it, you see that this is the result that you get. Now, those of you who are familiar with joins would know that there are many different ways to join depending upon exactly what you're trying to do. In particular, if you look at the data above, you will see that uh, here we have data for patients 1, 3, 4, and so on. Whereas in the demographics, we do not have an entry for patient 3. And similarly, so there might be patients for which one data frame has data, the other one does not. And but in those situations, how do we want to handle it? Do we want to keep that patient in the final data or not? And there are different ways of doing that. What it looks like, what this merge command does by default is something that we otherwise know as inner join. That is, it only keeps those pieces of data which exists in both data frames. That is, if a patient code exists in both the first data frame and the second data frame, then only that line is going to be used while creating this join. In other words, this is very, by default, it's doing what we call an inner join. Generally, I prefer to explicitly say that specifying the join to be inner using the how command, it's not going to change the result, but when coding, it is best practice to make sure that it is specified so that everybody at first glance knows that it is actually doing an inner join. What if instead of inner join, if I did a left join? And you will see what it does is any data that appears in the first data set, like the 9 rows here, each of them appears here. It has exactly the same number of rows as in the first data set, or rather what we call the left data set. So the number of rows here is same as the left data set. That's why it's called a left join. However, some of those patient codes do not appear in the demographics data. And for those cases, you will see that the demographic values are missing. It has an N in those cases. Uh, if instead I did right, I will see the exactly opposite effect. Um, the It has all the patients that appears in the right data set, the demographics one. But if it is not there in the first, then you will just have the concentration values missing with NaN. So we saw inner join, which takes the intersection, which saw the left join, which takes everything from the left data set, right, which takes everything from the right data set. And the last one is outer join, or also called full join. So if I do outer, then we see this. So what it does is it has entry as long as a patient code exists either in the left data set or in the right data set, it will take it. And uh, if it is not in the left data set, you will see an NaN in the time and consideration fields. If it is not in the right data set, you will see NaN in the demographic fields, right? So this is how we are doing join in Dataframes. The command is merge, and you're using how to specify the type of join. This is something you will be using very frequently whenever you're processing data in multiple CSV files. Okay, so I think that gives you a general overview of the various data frame commands. I am not going too deep into every possible syntax because you can easily look them up in the documentation or just ask, AI to generate it. We have now about 35 minutes left in the class, and I am going to now pivot into the topic of data fitting that we had started last week and in which we had also done the homework exercise. So again, I will put a brief pause in case you have any questions on the data frame before we jump into data fitting. Okay. So last week, what we did is uh, in the class, we had gone over how to fit our one compartment model. And then in the homework assignment, you were asked to uh, produce, just modify it to also fit data to a two compartment model. So I'm just going over the code. I will go over line by line to just explain everything again. We use the packages NumPy because it's more efficient to handle numbers with it. We used matplotlib to plot. We wanted to see the fit visually. This was the sample data, time points, which is an NP array, and observed concentrations. Then before we fit, the first thing we had to do is to define the model. We define the one compartment model like this. The arguments, the first argument had to be the time, which is the X value. And after that, the list of parameters that goes into the model. So in the one compartment model, you have two parameters. In the two compartment model, you have four parameters. And this is the expression for the model. NumPy allows you, even though it looks like it is a scalar expression, but in fact, NumPy uh, allows you to take vectors as an input. That is, in this particular case, if T is a NumPy array, the result is going to be a NumPy array too. Right? So this one is A times e to the power minus alpha t, and this one is A times e to the power minus alpha t plus B times e to the power minus beta t. And then we used another Python package called SciPy, and from that we imported the function curveFit. And in order to do a curve fit, we need the following. We need to pass in the model. Or we also saw if we just wanted to know the syntax of curve fit, all you need to do is actually let me connect first. If you don't connect, you're not going to see any autocomplete or documentation. So now if I hover my cursor over, I'm going to see the syntax of curve fit, exactly what parameters it takes and what they do. Right? So the first parameter is the model, which is just a function. Then the time points, the X data and the Y data. Then the initial values. and then a volatility, which kind of affects the time steps in the curve fitting process, and then the bounds. So the bounds within which your solution will be restricted to. And once you do the curve fit, it's going to return this result, covariance, and the optimized parameter. Now, one other thing I did not mention last time, that this optimized parameters is actually a tuple, a data type that we learned today. So when it is a tuple, you can reassign the values. This is a tuple with two elements. So by doing this, we actually reassign the values, the two elements of the tuple into two different parameters. And then you were asked to modify this to do the two compartment model, which many of you did, which essentially required you to just replace the function and also change the initial values to have 4 parameters instead of 2. One note some of you may have noticed while using the curve fit is that if you start with the curve fitting is somewhat sensitive to the initial values. If your initial values are a bit too far away, sometimes it does not find the right solution. It gets trapped into a local minima. But otherwise, it would be able to find something. So what this code does is it fits using the two models. So this is essentially what you were asked to do in the homework exercise last week. Now, what we are doing today is introduce you to one of the AI ML methods. And this is a random forest. A random forest, if I were to describe uh, in short, the basic philosophy of using AI ML methods is that what if I don't know what is the right model? The approach that you saw previously, someone had to know that the best fit for the data is either using a one compartmental model or two compartmental model, and you have to write the specific expression for that model. In order to do so, you need to have some familiarity or some understanding about what kind of function would work best. If you have that, yes, you can fit it very well. You would have seen that the one compartmental model did not fit that well. The two compartmental model fit quite well. Uh, but you just have the data and you know nothing about what model is going to fit it. And that is where AI models are best when you do not know what model is going to work. So in other words, the random forest model is, you could call it a one size fit all models. I don't know what is the exact model. I just have data and I'm going to calibrate this model. So it has, in this particular case, um, while the one compartmental model and the two compartmental model have very few parameters, one has 2, the other has 4. But AI-ML models typically have lots of parameters, like you would have heard, right? The LLMs have something like 30 billion, 70 billion parameters. In this case, the random forest model that we are using does not have billions, but it still has in hundreds and thousands of parameters. So what we are going to do first is just use the default random forest model. And what you will notice is how little it takes for you to use an AIML model. Here is my X points. I just reshaped it. Um, the data had to be a column vector uh, in order to be fed into this random forest model. And Y is the same as the observed concentration. So here I have only just changed the shape. I call the random forest regressor, and I simply just create an instance of this model, and I don't tell it absolutely anything. There is no exponential functions. There is nothing. Uh, just the same one size fit all random forest regressor. And then I say fit, and then I use the fitted model to predict. You know. And so let's just see how the whole thing turns up. All right. So here is the result. On the left, I'm plotting the the fits that we got using the one compartmental model and the two compartmental model. And on the right, I'm plotting the fit that we got using the random forest model. So what you will notice is the random forest fit is, it's not as great as the two compartmental model, but it is still impressive given the fact that you did not specify any model. You just gave it the raw data and asked it to just run with it, you know. In fact, what you will see is that if instead of if I just tweak the parameters a little bit, uh, all that I'm going to do is change a parameter which allows the model to overfit or overtrain, which means like, you know, uh, even though the model may have noise, you're just allowing to fit every single point. Actually, did I do that right? Now I'm plotting it. Okay. So if I simply change parameters to allow it to overfit, you will notice that this model actually exactly. Well, this is just to demonstrate that it has the ability to fit it exactly. Not that in practice you want to do it. In practice, you actually don't want to overfit the model because it is less useful when new data comes in, right? Okay, so what we demonstrated it here is how just simply using the random forest model. Uh, One other thing I will highlight here is we also showed another feature of matplotlib, that is how to plot two things side by side. In the last examples, you had just seen the plot command, but here you will see that there is a subplot command that I used. So I'm just going to explain that also, what exactly I did. What the subplot command does is you are able to say that I am actually going to have multiple rows, multiple plots. I said n rows. It means the plot should be arranged in one row and two columns. The figure size is 10 by 4, and the matplotlib is going to decide itself how it's going to divide that space into the subplot. Share y equal to true, that means both of these plots are going to have the same y-axis. If if it was false, then they were allowed to have uh, different y-axis. For example, this one is log and this one is not log, right? But if they're shared, then whenever I change one of them to have the log axis, the other one changes as well. So they both share the same y-axis. Share x means they both share the same x-axis, and so on. The output, you will see the it has this figure variable and it has a tuple of each plot. If you Here I had specified one row and two column, that means it's going to be two plots. So you have ax1 and ax2. If I had specified say two rows and two columns, I'm going to come back to the topic of um, fitting. So what we did here is we used the random forest model. We were still fitting data from one x value to one y value. The x was time and the y was concentration. Now the big, well, for one-to-one, yeah, it's fine. It did actually a little bit worse than the two compartment model. But you start seeing the main real advantage of these AIML models when there is more data and when in fact you are trying to use more than just one factor. If you have like 5 factors, right? So let's try something else. Let's go to this second sheet using random forests with multivariate models. Okay. So what we have here is we have another PK profile data. We just read it from this URL, and this is what the data kind of looks like. Actually, we can just go to this URL, just the browser, what it looks like. Data kind of looks like this. It's pretty large. It is on more than 1,000 data points. And the data that you have is patient code, time, concentration, age, as well as some graphics data. We don't have to do any joins because it looks like it's already joined. It has both demographics and time concentration data in the same data frame already. What we want to do with this data is we want to learn how we can do prediction, not just using time to concentration, but how to incorporate all these five other factors as well. And the fact is, with just time concentration, I had some idea that okay, it may have been a two compartmental model, but how to use age, sex, height, weight, food status, and sequence, how does that go into what kind of a model should I use? I have actually no idea. And therefore, I am going to say, you know what, let the random forest model take care of that. Okay. So here what we did is we just took a peek. We read the data into this data frame, and by using the head command, we are looking at the first few rows of the data. Then using plotly express, I'm just plotting the data individually. There is data for many patients, like we have about uh, maybe more than 20, and I'm plotting each patient's data separately using a line. And I've just decided to color them based on the sex so that the male ones are blue and the female ones are red here. Uh, Another thing I want to point out is that the last time we plotted, we used a package called matplotlib. In this case, I'm using another package called Plotly. So just to highlight that in Python, unlike R, in Python, packages are more diverse. Many different packages are popular with different people. So while some people stick with Matplotlib, some people use Plotly, there are others who love Seaborn, and then there is Bokeh. So there are a number of different packages which are popular with different people. So you will have a diversity of things to choose from. And in fact, there is another package. I'm missing the name of it. It's given in one of those resources. There is a package which is exactly identical to ggplot in R. So if you like the syntax of ggplot in R, then we can use that package, which is the exact equivalent of that in Python. Okay. So what I did, um, what I did after this is I now wanted to use random forests on this data. But instead of coding myself, what I chose to do is I asked Gemini. Basically, I just clicked on this and I gave it a prompt. So everything that you see from this line below was actually generated by Gemini. And I did not edit it at all because I wanted to go over with you guys, like just as a demonstration of how AI does coding and what you need to do. And after AI has done coding, you may also need to do your own thing to clean up or fix some errors. But what you see from this point below is a demonstration of um, coding using Colab. All I did is basically I clicked on this. Um, Actually, where is it? You will often see when you click on Colab, you will see a link like this: start coding or generate with AI. So what I did is I basically just clicked on this, and let me go back here. And this is the prompt that I provided. So let's just read the prompt. So I asked AI to split this data frame into two halves. Train a random forest model on the first half to predict the concentration column, and then validate the model on the second half. So if you're somewhat familiar with AI ML techniques, you will notice that this is a very common thing that you do. whenever you have a big chunk of data, uh, you would want to split the data into two pieces. And the reason why you need two pieces, because if you use that entire data, let's say you use that entire data to train the model, the next thing you want to find out is the model good? Is it, how good is its predictive capability? And to do that, you need more data, right? You need to run it on some data and see if it is matching. However, if you use the same data that you use for training, and then if you use the same data in order to validate, did I, what is the error? You That kind of defeats the purpose. That the model may have been overtrained on that piece of data, and when you try to validate it will tell you, oh, it did great. And then when you have new data, you will find out that the model was actually not that great. And so therefore it's a common pattern in AI/ML that you split the data into two parts. The data that you use for training should be different from the data that you used to test it, to validate whether the whether the trained data actually fits it well or not, right? So I asked Gemini to split the data into two halves first, then train the random forest model, and then do the validation. So let's just cruise over what happened here. And just to remind you, whatever you see from this point below was actually generated. It was generated by Gemini verbatim, and I did not type any of this code below. So looks like Gemini decided to split the data into subtasks, and the first part is to split data into two halves. From what I see here, it used a very simple technique. It found the number of rows and it divided by two, and then it used this split ILOC to create first half. So the original data had 1200 rows, and it created two pieces, one each with 600 rows. Pretty simple. Um, and yes, of course, you have the link to this notebook, so later on you can just go back and you can read this comment carefully. You can play with it, and as I will tell you in another 5 minutes, this is also going to be your second week's homework. I'll tell you more about it in 5 minutes. Okay. Uh, the next thing it did is define the features. It basically took that the concentration column um, as the Y data, the target, and it took everything other than the concentration column as the X data. So that means the concentration is you're predicting, that is Y, and everything else, age, sex, status, weight, all of that is your input factors. So it's not a one-to-one, not just time to concentration, but it's taking everything as input. And then it basically, it essentially did the same. It took the first half of each piece as the training data, and then it was just a matter of calling the random forest regressor. If you recall, you don't really need to tell what model you need to use. It's just going to use the same one size fit all random forest. Uh, it tried to fit it, and then it ran into an error. So yeah, your AI coders have gotten very good at working just like human coders. That it tries something, it runs into an error, it looks at the error, and it moves ahead and it figures it out what to do next. The error it saw is that some of the columns in the data, in the input, were actually not numbers, they are strings. So you can't really use a non-number field in order to predict as an input to the random forest model. So it needed to handle that. So it got this error, and what it decided to do is it decided to drop um, these fields, the string fields, passion code, food status, and sequence from the dataset. Drop means it's just going to ignore it and not take that into account. And it did try it again. It again saw an error, so looks like it missed something. Uh, could not convert string to float m, and this is coming from the sex column. Now, in this case, you will notice that the model took another approach. Instead of dropping the sex column altogether, it converted that column into category. A category is almost like a number. So instead of this column being two strings, it's just going to be almost like 0, 1. It, few set of discrete values. So that is what it did. LLM word, it's called one-hot encoding. When you convert a string that can have multiple values, and if you convert it into a set of categories. And now well, third time is the charm. And looks like in this case, it was able to fit. It got the data. And then what it did is it took the second half of the data. So the first half of the data was used into the fit. And the second half of the data is used as the test. So it used that test to do prediction, and it calculated the difference, and it reported the R square, right? So Gemini was able to very effectively, take my prompt and come up with a very decent implementation of fit, multivariate fit. So what you might see that, well, it did something, but maybe there are certain things it did not do well. If I were to not nitpick, one of the things I did not like is that it divided the data exactly into half, which means maybe the same patient have actually, maybe I can check what it did. Um, DF half one and DF half two, right? DF half one dot tail. I'm just looking at the end of the first half. Oh, did I miss it? I have to run all. I think it's defined already. All right. And let's half two head. Actually, yeah, I take my criticism back. It looks like it's okay. So the first half ends with patient code 35. The second one picks up with patient code 36. Okay, fine. So no patient is appears in the both the training and the test code. Yeah, training and the test code. However, there are more things I did not like. One is that it completely ignored food status and sequence, whereas I would think that they are important. Whether it was whether the treatment was applied or not, right? So that if I were to rectify and redo this, what I would probably do is instead of completely dropping food status and sequence, I would also convert food status and sequence into a category, just like it did with sex. Other thing I did not like with this code is that it just predicted a mean square error for some number, fine. But I would have wanted to do some more plots and visualizations to see how exactly the fitting is looking like. So for example, we could plot the predicted values for different values of weight and height, and try to get a better sense of how the model exactly what the fit actually looks like. So what I have done is I have written some of these suggestions in the slide about how you can modify this sheet. So that is basically your week 2 homework. That is, you take this particular notebook, see what the AI generated code is like, clean it up, you write your own version, and try to address some of these issues. Two things that I told you are just suggestions, but you can make other amendments that you see fit. So basically, I am kind of intentionally making this exercise a bit more open-ended. Um, you guys are all in grad school, so you know where you can come up with your own thoughts, you have your own views about how you would want to do it. So yeah, the homework too is a little bit open-ended, and that is, I'm not telling you exactly what you need to do, except that you want to clean it up and improve what the AI has done in your own way. I just made two suggestions. Okay, so I'm going to stop here. I think everything else is already, pretty much everything is described in the slides. You will find it in Google Classroom. And that's all. So I think I have just 2 minutes left. So I'll just pause for any further questions. Yeah, I think someone asked, is it a good practice to divide 50-50 or 80-20? Which one is a better option? Yeah, I think it is quite subjective. I can see your point why you'd want 80-20. That is, um, you use more data into training. Unless you find that if by doing 80-20, you might find that the test set is very small and maybe it's not capturing. So I would think the answer depends upon really how much data you got. You may have to also look into other factors like, is there enough diversity in both the test data and the test data? Like, let's say you tried 80-20 or you tried 90-10, and it turns out that the test data only has one patient code and two patient codes. In this case, maybe it's not going to be a very effective test. So if you might have more questions after you have a chance to go through the notebooks, so feel free to just go back to the classroom, and there you can post your comments. You can put your comments on the assignments where the announcements are made, so they are all grouped together, and I will be checking the comments time to time. Okay, so I think we are at the end. So if there is no other questions right now, I will just stop here, and you do have the resources, you have the links where you can reach me and post further questions and find the material. All right, I'm going to stop sharing. Okay, so that is it then. So we will just call it a day here. We will see you next week, and of course, we will be in conversation in the classroom. All right, thank you all.